Let's start. Hello everyone. My name is Sergei and Konstantin. We're system administrators and we will tell you how we chose SQL for our 1C, how we made this choice and why we think that we were successful. Stereotypes, it's such a thing in our life. Usually they're not 100% right or wrong. They just help us to make a decision. It's like a pattern. So here on the slide you can see animals going through the river. They just do as everybody else does. And in their position it's correct. They don't spend any resources. They just do as everybody else does without thinking. And sometimes it's important not to follow the common trends and stereotypes, but to think which choice is good for me in this particular situation. KNOPKA company is one of the biggest in Russia. We have more than 100 accountants in our company. They're using 1C and other software. So just so you can understand our level of load. At night there are no accountants, only a cat stays in the office. And also our robots work at night. They generate acts and different other documents and also accounting databases. We are using 1C flash technology in our work. Does anybody know? I will just explain you briefly. It enables us to provide 1C solution to the users. We have several databases which are governed by a common structure. These are 1C processes and information database. And on this slide you can see that this system is very well scaled horizontally. So if we need a new database, we just create it in a certain cluster, etc. So when we started it, we used a stereotype. We took SQL Server, 1C software and started. And it worked for some time. The number of users was growing. And then at some point we faced that different databases started to influence each other. And we felt uncomfortable at this point. And databases also expanded. And we, for example, faced a situation when one database collapsed. We had like 100,000 broken links, and it took several days to rectify the situation, and the database was unavailable. So we understood that we need to do something, that we need to distribute the load between several SQLs. And when we thought about Microsoft, it was too expensive, and we decided to look at Postgres. We started to look at it, to read about it, to understand what is it. We knew some basic information about this database, but we had no experience with 1C. And we started to investigate the stereotypes and the feedback. And these are actual quotes. For example, that Postgres is 10 times slower. Of course, it's quite scary to install such a software. Next, it doesn't support many users. And also there is an opinion that it's not recommended to start 1C on Postgres. So once again we got scared, but are all those stereotypes true? And we're brave guys, so we just started it. Konstantin will tell you more in detail. So we created virtual machine working on Linux Debian, and we installed 1C server application and loaded Postgres build from the official website. At the time it was 9.4, not the latest, but we decided to avoid risks and to install something that 1C recommends to be safe. We installed several databases in Postgres, and then we duplicated based on the number of licenses that we had at the time. So we installed basically we had self-sufficient nodes, and we distributed them on the hardware. The load started to decrease, and it worked well. We haven't seen any sufficient problems. So, based on our opinion, everything is fine, everything works, we can relax, but in our company we usually measure everything. So whatever results we can measure, we do. For example, here we track our tasks, different indicators, and we added one square, which means accountant's feedback and feelings from 1C. So we put it in Google Docs and then analyze it. These are information databases with big volumes of data. These are the columns for big database and the most common operations. Everything is the same, distributed on different hardware, and so on in this table we saw that some blocks were green and some were red. So we decided to try to understand where it comes from and to rectify this situation. We decided to start from the beginning and to look how we approached our system and what we can change in our system. So it seems that we can bypass Linux server application for now, because we have several databases, and we started to look how we add those databases. So look here, this is our virtual machine. We do not show 1C server, we just show you Postgres, cluster main, which is initialized by default. And when we need to add a database, we simply add it. And then we have several databases. Let's say the first one is a big accounting database. The second one is smaller, less loaded. This is payroll, for example. We don't need it every day. Third one can be something service, for example. Just not to put it on a separate machine, we keep it there. So now look in the configuration file for this cluster. It's only one, and it was used mostly for the load of the big database. So the other databases, they were not optimal. They were like add-on for the heavy, high-loaded database. So how we decided to find a solution? We decided to divide again, but how? There are several options. For example, we can distribute each database on a separate machine and work with them inside different hosts. But why do we need so many machines? It's not clear, because later it will be very difficult to administrate, much more difficult. So that's why we did it this way. We started several copies of PostgreSQL on one machine. Each one had one separate cluster, and inside each cluster only one database. So accordingly, in the settings for each database, we had separate settings for each database, and they could have been adjusted separately for each database, and they didn't influence each other that much, despite the fact that they were installed on the same machine. So, for example, this cluster content is on a virtual hard drive, which can be migrated to another storage pool, for example, an SSD drive. And then the settings can be adjusted so it can work correctly with the data written on the SSD drive. So again, we distributed it even more on the hardware, optimized it even more. So this is one of the cheapest solutions and less time consuming. That problem that we showed you on our previous slides, it became even. Maybe not perfect, but still it started to work much better and much more even. This is the administration room, and as I've said, we measure everything. In order to become better, you need to understand where you are right now. So every problem which we've had, we started to measure. So try to measure. This is very useful, and try to keep record in which way you're going. And when you think about it, measure it, record it, you will be able to even the load, and now it's much more even and much more, the performance is higher. I'd like to say a few words also about backup, because this is very important. System administrator of Postgres, let's say he wants to make a couple of backups. Most probably he would choose pgdump in archive format. I will remind you that pgdump has several formats: texts, archive, directory. We chose it because it's a very simple way to create a backup for a database. You just start it and the backup is ready. This is archived file, so you can move it wherever you need it. And then you can apply PGRestore utility to restore in several threads, which is much faster for recovery of your database. But also there are some negative sides They're not so significant, but still you cannot create archives in several flows. Directory format supports archives in several threads because you can indicate the folder and then it packs each table in an archive and stores it. And there is no issue to do it in several threads. But there are too many tables, a few thousand tables. And actually to work with a few thousand files is not very convenient. So this is why we chose archive format. Also, pgdump cannot save global objects. You need to install this database somewhere else on other cluster or on other machine. pgdump old can save global objects, but it doesn't save all the databases. So this is not exactly what we needed. So basically this is a replication of a database, and if you need to restore within a certain period of time, you will get a copy after you created a backup. Another option is PG-base backup plus WAL archivation. This was very convenient for us because our decision was to create one database and cluster. And in the previous option we would have several tables, and if we needed to restore, we would have to restore several databases, and this is not what we needed. Also, there is control of data transfer speed. For example, if you don't have a replica from which you can create a backup, and you need to do it, for example, during the daytime, and it's not very urgent, and you don't want to disturb the users so they will not feel any additional load, this will be handy. And once again, if you want to create a replica using PG-based backup, you can create a start point for your servers. The negative side, that it's not that simple as pgdump. It requires some scripts, restore file, in which you need to put the necessary parameters, transactions, and also during archivation you will need more space for WAL storage, which is a natural effect, and also you will not be able to understand the final size. You need to try. This is also adjustable. I will tell you a little bit about our database, which we're using, just very briefly. For us, we decided that each database size should be not more than 100 gigabytes. This is convenient for us, this limit. We have horizontal scaling, and for us it's very easy to stop at 100 gigabytes and to start a new database. We have about 60 connections to the database. These are not users, but also idle connections, which one C server keeps constantly with the database. Sometimes it closes them. And on the old platform, sometimes it didn't close these connections, and it could overflow by memory, for example. But starting from 3.9 and Postgres 6.9.6, it closes such connections. So it's approximately 60. Index utilization is approximately 40%. It's not as much as we would want. But utilization also comes from robots, which can create unforeseen load. It's different every day, and it's hard to adjust. We use approximately 4 cores. We have several databases on each server running, and I cannot say that we will not use anything else in addition to 4 cores, but it can be achieved, for example, by limitation of workers, parallel processes for reading, or something similar. And operation memory, 10 gigabytes. So 100 gigabytes database works perfectly in such amount of memory without any difficulties. I will tell you a little bit more about the typical load for the average database. Here you can see that we have much less transactions during daytime than during nighttime. This is because of our robots, because during night lots of service transactions happen and robots work as well. And during nighttime it can be up to 1.5 million. So currently we have about 10 accounting databases. So if you multiply all this by 10, this is how our Postgres works with 1C. And also we have a very interesting figure. When we started to move to Postgres, we decided to measure the availability, the uptime of the service. And this is not separately 1C and PostgreSQL, but the whole system with all the servers, applications, and up to the particular database. When we started, we measured and it was just 49.8. So most than half of the time something didn't work well. So accordingly, this is again about these questions where we are right now, and just recently I measured again and we have 99.48%, which is the same. This figure shows and proves that 1C and Postgres can work together very well and the stability is high. So do not be afraid to choose Postgre. This is quite stable and simple. You just install it and use it. Yes, after some time it will become more complicated, but still the entrance is very cheap and it's very convenient. Do you have any questions? I have several questions. you divided several Postgres databases, which means that you use different ports. Yes, that's correct. Yes, different ports. As far as I know, 1C doesn't allow to change port, connection port. No, it actually allows. Okay, but you are saying that you have fresh. But here you divided fresh in several. No, in French, horizontal scaling will be on the level of big databases. And in each database, you will use separation as well. So several fresh, no, fresh one is it's single fresh. And let's say it has 8 accounting databases, big databases. So it's 8 informational systems are distributed. That's clear. And the second question, what is utilization of indexes? What does it mean? Basically, this is about reading, about entries, strings, with help of those indexes, the reading of the whole table is performed. We have 40. This is together with accounting and with robots. We are not bragging about this figure, it's just the way it is right now. So on one host, both 1C and Postgres are working. So we're using pipe or TCP/IP. This is how we started, and it was okay for us. Servers worked fine. But for example, for accountants, it was not convenient to use network routes. So this is why we moved the server applications back to Windows. And what is the ratio of application servers and Postgres servers? We have 6 application servers. We have also one separate server only for configuration, for example. And somewhere the load is isolated for separate processes. And Postgres we have about 5 or 6 virtual machines, and on each virtual machines we have several databases, several instances, approximately 3 or 4, from 4 to 7. It can be flexible because it's easy to migrate. That's approximately like this. Sometimes we are doing evening when we don't like something. The utilization of hardware, for example, is not optimal, so we migrate it in this case. And how you measure the performance of Postgres? We take all this information to Zabbix, and we're using this module. I forgot the name, but nothing special. We are not measuring anything special. After the recent presentation about the vacuum, we now actually want to measure vacuum as well. Maybe it will be our next step. Just to measure it. This is standard utilization of memory, of servers, databases. So this is 1C. No, this is only on the level of SQL. It's clear, thank you. Anyone else? Which version of Postgres are you using right now? 9.6. 9.6, the latest one. We moved to Postgres Pro because it's simply more convenient to use. One C 8.39. To change a platform, it's a very big task because it needs to be tested, all the changes needs to be rewritten, so this is why we are not changing the platform as often as we would wish to. For store purposes, we can use only backup because in Postgres this is the only way. We are doing replication. I mean, you have replication, so if one node is not operational, then you can use secondary node. No, not automatically. We maybe will use PG pool, but it doesn't work well with 1C. Okay, so anyhow we will think about it. Classic developers mostly noticed some particularities, and for 1C developers there was no difference at all. There are several databases because you cannot grow infinitely one database. It's very expensive. Sometimes we need to test, for example, but how? Again, it should be reliable. We distribute it in several sections and servers. If something doesn't work, it's just one small element. It's not the whole system. But there's also fresh command and recommendation from 1C. So what they suggest? They suggest to use one database, one system, and inside, on the Postgres side, to distribute the tables step by step and to achieve scaling in this way. And reliability can be assured with code standby replica to make backups from replica. And this is why it's not clear. Do you want to go back to the general fresh, or you will stay like this? It's very interesting because initially the idea of multiplication of nodes came from the developers of Fresh. We sit down together with them And we decided to try this as well. So maybe we have different information. And once again, the presentation was about choice of SQL and stereotypes as well, because we also used applied stereotypes sometimes. But you didn't go back, and that's nice to hear. But still, there were people who were against it. Actually, no. Sometimes we had some thoughts maybe to go back, but then no, we kept going forward, because actually in general everything went quite smoothly, and we didn't discuss. Sometimes there were some particularities in operations. So it was not the same as before, but it was quite simple and easy to solve. So we're quite happy with the system. The biggest difficulty were the frozen connections. It was very unclear why it happened, but in the end, apparently it was a bug of the platform, and we solved it together with people from PostgreSQL. They worked a lot with 1C at the time, so thanks to them, to 1C and to Postgres for their help and assistance. Okay, let's wrap it up. Thank you very much.